examples of toxin, heavy metal, pesticide, cleaning compound, or food additives. The one that when we talk about like GMP, last time we talked about like sanitary operations. So you have like the what? We have apa Syahir? We have apa? Okay. We already discussed about the soap and detergents that involve, okay, pesticide, like rodenticide or insecticide that you might use during the production. And then any food additive, if let's say you use any kinds of pH regulators, any preservative, then you can put inside this chemical hazard analysis. Physical, if you receive like a flour, what is the physical hazard involved? Flour, stone, apa lagi? What else? Stone, insects, flies, okay, cockroaches, more towards that. Probably will have like some kinds of wood, metal, plastic from the container, the packaging container, and radioactive. If let's say you deal with what? Preservations of fruits or vegetable, right? So you introduce like cobalt, cesium, or uranium in order to preserve the shelf life. Or the other one, if you talk about like meat products, maybe you introduce like the radioactive towards that. Okay. So a hazard is more towards that something that let's say we consume, then it can cause like it will give an effect to the human health. Whenever we conduct hazard analysis, okay, probably you know about this. We have two stages. One is a risk, the other one is a severity. So the differences between risk and severity is more towards that risk and severity. Risk is what? Risk is, which one is critical, risk or severity? Which one is critical, between risk or severity? Severity. Okay, so severity probably it can cause death. Right? Risk is more towards that you still can treat them, you still can treat the human. If let's say you consume the hazard, kalau tertelan apa batu ke contohnya, it will choke and then probably the hospital berobat kan. But if let's say severity more towards like food poisoning, will cause like paralyze or death towards the human health. So risk is more towards the likely occurrence of the hazard. It's not really like, not to say not significant, but it's not really critical as a severity. So severe is more towards the seriousness of a hazard. Let's say we consume salmonella, so we have like the diarrhea, vomit, and so on. And whenever we talk about like hazard analysis, basically there will be like one section that we need to identify what kinds of preventive measures. It's like if we have like stone, how can we remove this stone from the ingredient? So maybe there will be like another process that you need to have like a sieve stack, or you use like a sieve to remove the stone. Okay. Preventive measure is more towards that corrective actions that we need to take in order to make sure that the hazard won't reach the customer. If let's say we have the microbiological hazard like salmonella or E. coli, what is the effective process or measures that we need to take? What is the preventive measures that we need to take for salmonella? Cooking process, okay, or heating process, right? So each of the hazard you need to have a preventive measure, with cleaning and so on. Okay, number 2, identifications of CCPs in the process. Let's say how to identify whether it's a CCPs or not. You heard about decision tree? Decision tree. So we usually use the decision tree in order to identify whether it's a CCPs or not. Okay, I think if you look through the HACCP standard here, we have like actually the decision tree. So we have like a couple sort of question, and then for each of the process, for each of the ingredients, you need to go through this one. So means that you need to ask the question and answer whether it's yes or no. It will convey to whether it's a CCPs or not. Okay, so that's how you identify or you determine the CCPs is true CCPs or not. Usually for CCP, you need to have like a hazard. And at the end or the next process, there will be like a process on how you can control, not with like preventive measures. Okay, how you can stop the hazard, right? So basically, CCP is more towards that a point. So whenever we talk about point, it's more towards the process. Example, cooking is a CCP, freezing is a CCP, pasteurization, sterilizing, anything related metal detecting, more towards CCP because they contain hazard. If let's say we just release the hazard, probably it will cause the risk or severity towards the human health. Okay, so we can use the decision tree in order for us to come up with to identify whether it's a true CCPs or not. Okay, and this is actually another set of examples decision that we can use like Q1, Q2, Q3, Q4. For example, let's say number 1, do control preventive measure. Apa tu? Acid. Right. So is there any preventive measures that we have? If let's say, okay, we know that the ingredient contain like simple one, yeah, coliform. The water probably contain coliform. Okay, so is there any preventive measures that we can put in our process in order to eliminate this coliform? Ada ke tak? If ada, so that is considered as a CCPs. Okay, so you answer like a yes or no. It's like yes. Number 2, you continue with number 2. Is the step specifically designed to eliminate or reduce the likely occurrence? So means that if we have that next step, example like the heating process or sterilization process, can it reduce or eliminate the hazard? If it can, okay, yes, automatically it's a CCP. Or if no, then continue with the number 3. Okay, so usually number 1 and number 2, if you have the answer is yes and yes, automatically it will be the critical focal point. So that is the critical. If not, continue with number 3, or if not, continue with number 4. Okay, so you can actually identify which is the real CCPs for the production line. Okay, now whenever we talk about like CCPs, okay, CCP we know that common one will relate with the temperatures. Okay, temperature. So we have like a frying, chilling, baking, a common one. It's like you need to we need to avoid 5 to 16 the temperature danger zone. So you need to avoid that range. Okay, so anything must be below and beyond that 60 degrees. Like feeding sometimes can be as a 60 degrees too, because you actually play with the temperature. If you go beyond that 60, maybe you will have like the microbes that will grow inside the product. Okay, specific sanitation procedures like a sanitizing step. It's like using what? A common one. Hot water is a common one. But you can also, in aseptic packaging, you want to sterilize packaging material using what? Using hydrogen peroxide. Okay, we spray like hydrogen peroxide on the packaging material, and then you soak with the hot water to remove the residues. So that one is considered as a product, this one is a product, must be aseptic. Aseptic means that it's sterilized. Then we must be in a closed system, continuous process, combined with the packaging material. So this packaging material must be sterilized together. Then they combine and you will have the filling process, beverage drink. Right? UHT, ultra high temperature. That one is an aseptic packaging. Dash lady. Okay? So whenever it comes here, you'll have like the filling process. So filling process takes place where you have like, the beverage method would be like in a flat shape products, packaging material. And then when it comes to packaging process, it will form into like a macam ni, jadikan kotak, kan? It will flat and so on, masukkan, and then there will be like transversal, longitudinal seal and so on. So then the output is the aseptic packaging product. Similar with the report. So specific sanitization procedures is example. Let's say we talk about H2O2. H2O2 is the hydrogen peroxide that used to sterilize the packaging material. So we consider that one as a CCPs. Product formulation control. Let's say whenever you deal with like a probiotic, right? Adding culture into the food product like bacteria, lactobacillus, leuconostoc, streptococcus, right? So you put in a dairy product, you ferment, and then there you have like the yogurt and so on, right? Product formulation control. In fact, it deals with salt concentration or in cheese making, adjustments of pH. That one will be under product formulation control. Preventions of cross-contaminations. This one is more towards the GHP, good manufacturing practices, but it's really not really critical unless if you talk about like there will be like a process where it shows like how you remove the byproduct. Okay, so cross-contamination probably the byproduct could be one of the factor to contribute the cross-contamination and certain aspect of employee. So if you look here, the most common CCP would be number 1, number 2, number 3. Okay, number 1, number 2, and number 3. Alright, and then this is another thing about the CCP. If you look at the critical control point, we know it's a process, and the most important thing is it must be continuously controlled. So temperature must be continuously monitored or controlled. What happens if you have like a low temperature or high temperature? Okay, high temperature won't give you like a problem. If let's say you have like deviations of the temperatures, what will happen to that batch? Cooking won't achieve up until 120. So it just achieve until 100 degrees. So what will happen? Still, it's enough to kill the bacteria, but you don't have like that in terms of product itself, probably it will affect the color and so on. Auto-corrected means that we can always, like when the temperature reduces, call the engineering or technician department and check whether the machine is okay or not. So they'll have like the downtime, stop, and then check the machine, repair and maintain. Required detail recording, verify, and this one more towards that we just fill out the form. We have the AQL form. Okay, for each of the process you need to have the AQL. It is actually important recording because one is for record keeping, the other one is for monitoring process. So we know that if let's say there's any product recall, means that you can actually look back at the documentation. So we can trace who is responsible for that problem. Okay. Requires calibration, measurables and objective. So it must be doable. And this is actually the template, the real template that we're going to use. Probably you identify the ingredients. Okay, at the top one is the ingredient or process. So if let's say you have like the 30 process, you need to have 30 ingredients. You need to identify to conduct hazard analysis for 30 ingredients. Or you have like 60 process, conduct for 60. Okay, and if let's say you talk about like potential hazard, okay, you cannot put like a biological, chemical, and physical. Yang itu memang straightforward, student buat. So what you need to do is actually you need to identify what kinds of biological hazards that might contain inside the product, okay, or ingredients. Inclusion or exclusion, whether it's significant to include as a hazard, or you know it's a hazard but still controllable, means that you can just eliminate it. Or probably if you have that hazard, maybe you can just, it won't give like any risk or severity towards the human health. Okay, sabar. Alright, is this significant hazard? Is this a significant hazard? Whether it's a yes or no, or the likely occurrence, whether it's high, medium, or low. So if let's say you have is a significant hazard and then it is a high risk, automatically the process later on is considered as a CCP. Okay, usually it will look like that. And severity of the hazard, whether it's high, low, or medium. So usually we just represent with H, M, and L. Kalau low is a CCP or no? No. Okay. High, CCP. Some sort like that. But sometimes high, but if let's say you have the preventive measure, it can be. It's not a CCP. Come up with the preventive measure. What kinds of preventive measures that we can use in order to prevent this hazard? Okay, and the last one, the last column is actually about the decision tree. So we have that question 1, question 2, question 3 up until whether it's CCPs or not. So that is actually based on the decision tree that we have just now. Okay, so you need to answer all that. And the last one before we stop for today is the critical limits. Okay, we already know the CCP, critical control point, but now we want to look in terms of the limit. So critical control point is actually for example, let's say if we do baking process, baking will be conducted at what temperature? 180. Common one, right? For how long? 20 minutes. It depends if you have like cakes or muffins, so it depends. Okay. Pasteurization, the common one is pasteurization, high temperature short time, 72 degrees C for 15 seconds. Macam mana tahu benda tu begitu? How do you know? That is 72 degrees C is actually pasteurization. How do you know it's a pasteurization critical limit? How do you know? Based on what? Based on regulation, based on literature search, based on reference. Okay, so establish critical limit. In order for you to establish one limit, you need to come up with the justification, documentation to support. More towards that UHT, ultra high temperature, must be performed at what temperature? Okay, 125 for how long, for example, let's say. So all of this temperature time, it's not only that we come up with our own, okay? It must be based from the literature, from previous study, from regulation. So we know that moisture level or water activity to make sure that microbe cannot grow in the product. So it should be less than 1. So by default, should be less than 1. Should be 0.6 and below. Okay, so it's dry. pH should be higher, like depends. Juice 4.2 and above, right? Titratable acidity, salt concentration in cheese making. So what is the limit? So you'll have the limit. If you follow this limit, means that inshallah you will have the hazard inside the product. Microbiological hazard. But if let's say you talk about like stone, talk about like dust, metal, of course you will have. requires like another preventive measures, like metal detectors, sievers, and so on. Okay. Alright. Last slide before I release you. Okay. So as I mentioned just now, how do you know? How do you know is pasteurization like the 72 degrees C is actually based on the references, literature search. Okay. Experimental studies. So there's a lot of experiment or research, previous research conducted in order to know the resistance of the microbes. That's why we have like the mesophile, thermophile, psychotrophic, bacteria, and so on. Right. So those resist towards the high temperature, those resist towards the cold temperature. Or you have like a mesophiles, like love to live between 5 to 60 degrees C. Okay, so that's why you want to avoid that TDC, temperature degrees. It's all based on the experimental studies and expert. So expert is more towards like your research lah. For example, like those who actually relate with the probiotic, siapa yang nak buat study macam micro and inhibition, dimeter and so on. So that one can be one of the evidence. So you need to have the evidence in order for you to claim, oh, this one, the microbe cannot grow at 80 degrees C, for example. Okay. So, any question for principle 1 until 3? Any question? No. So, I think that's all for today.